right, welcome back. Part 3, last and final part of this lab we would have done. All about salinity. One of your vocab words. So salinity, the measure of the amount of salt in water. Teachers already told you this is a quiz question, this definition. Specifically, what salinity is always measured in. So pause for a second, see if everybody remembers. Salinity is always measured in the unit of grams. That's too big. There we go. It's always measured in grams per liter. It's never measured in anything else. You always got to convert back to grams per liters. How much salt is in 1 liter of water? Metric system, liter. We just talked about it in math recently. Liters. Salinity and temperature, part 1 of the lab you did, have huge impacts on the density of water specifically. So this would have been the last part of the lab that you did to really tie things together. Here we have a tank of just pure water. No salt, just a normal room temperature thing of water, nothing special about it. You would have made bags that have 2 different salinities. We would have done some math to figure out, with this size bag, how much salt do I need to add? I already did it. So, yay you don't have to do the math. I had to do the math. Although I've done the math. Done so much, it's just committed to memory. And I've got 2 colors. Here's purple, here's orange. My purple bag is as salty as the ocean is. It's 35 grams per liter of salinity. On average, that's how salty the ocean is. And then bag B is just like our tank. Nothing special about it, just some tap water. Now, you're going to pause and make a prediction. What's going to happen to these 2 bags? How far are they going to go? Are they going to go all the way to the bottom? Are they going to just stay on the top? What is going to happen to them? So I'll give people a second to do that. But then, if we were doing this for real, we would have done it a bunch of times and make a graph eventually. But now we were just doing it with 2. So I'm going to drop in our 2 bags, and we're going to see what happens. So I'll just drop those in, let them settle. You eventually see that our purple bag is sunk all the way to the bottom. It's not coming up again. But my orange bag is floating. Since this water and the bag are the exact same water, it's just going to find a nice midpoint. If I tilted it, it would even just stay floating. Just this tank is not big enough to hold that bag, but it's just going to float. There we go. Might be some remnants of salt, but it floats. If I did it with this one's not going to suddenly float. It's just going to sink. Weird. Oh well. But moving on. But bag A sunk all the way to the bottom, not moving. My bag B floating on the top of the water now. So why is this? I know this is happening because of my salinity. Students, this sentence is there for you with the same blank, so I'm going to let you pause. Water with a blank salinity will sink as it has a blank density. The opposite is also true. You can even see it. This bag is still like a rock. It's all the way at the bottom. My orange bag, floating. Pause and fill this in. I should be able to write my sentence and say that water with a high salinity will sink, as it also has a high density. The opposite is also true. My orange bag is floating because this has a low density, because it has a low salinity. It's kind of our lab we would have done, that I did, just to go through our salinity and density. So my YouTube career is now over. Thanks for, sticking along.